Imagine a camera so powerful that it doesn't just take pictures of your face or your surroundings. It takes pictures of your very cells, your organs, even the tiniest biochemical activities happening inside your body. Not through X-rays, not through MRI, but through gamma rays, the most energetic form of light in the universe. Sounds like science fiction? Well, not anymore. Scientists have just developed a nuclear gamma ray camera that promises to revolutionize how we look inside the human body. This breakthrough could transform the way doctors detect cancer, track brain disorders, and understand the hidden details of human biology that no tool has ever been able to capture before. In this video, we'll take a deep dive into this extraordinary invention, what it is, how it works, why it's so groundbreaking, and what it could mean for the future of medicine and even our survival as a species. So buckle up, because this is not just about cameras or hospitals. This is about redefining what it means to see the human body. Let's start with the basics. What exactly are gamma rays and why are they so special? Most of us are familiar with visible light. That's the small slice of the electromagnetic spectrum our eyes can see. But beyond that, there are other forms of light: infrared, ultraviolet, X-rays, and then at the very top, gamma rays. Gamma rays carry the highest energy of all. They can pass through almost anything, walls, metal, and of course the human body. Because of this, they are both dangerous and incredibly useful. In medicine, gamma rays are not new. They've been used in PET scans, positron emission tomography, for decades. In PET scans, a small radioactive tracer is injected into the body, which emits gamma rays. A scanner then detects these rays to produce an image of the body's internal processes. But here's the catch. Traditional gamma ray detection has always been limited. The images are often blurry, lacking detail. Doctors can see general regions of activity, but not the fine-grained details, not the individual cells or precise biochemical interactions. That's where this new invention comes in. Scientists have created a nuclear gamma ray camera with unprecedented resolution, capable of zooming in on the tiniest details inside the human body. This is like going from looking at Earth with the naked eye to suddenly seeing it through the James Webb Space Telescope. So, how does this new gamma ray camera actually work? The secret lies in advanced nuclear detectors and computational imaging. Traditional gamma ray cameras use a material called a scintillator, a crystal that absorbs gamma rays and converts them into light, which is then picked up by sensors. But this process wastes a lot of information. Gamma rays scatter, blur, and lose resolution. The new system uses a specialized nuclear pixel detector, which can track individual gamma rays with extraordinary accuracy. Instead of just knowing that a gamma ray hit here, it reconstructs the exact angle, energy, and path of the ray. Think of it like replacing a grainy CCTV camera with a 4K ultra-high-definition camera that records every pixel in stunning detail. What makes it even more powerful is the use of AI-driven image reconstruction algorithms. Gamma rays don't travel in straight lines like visible light. They scatter. To piece together an accurate picture, you need advanced mathematics and machine learning. The new camera integrates physics with AI, reconstructing images at a resolution never seen before in nuclear medicine. For the first time, doctors could see living tissues at the molecular level without cutting open the body. Cancer is one of the world's deadliest diseases. Early detection is everything. Traditional imaging like MRI or CT scans can show tumors when they grow large enough, But microscopic cancers often go unnoticed. With this gamma-ray camera, doctors could detect tiny clusters of cancer cells before they even form visible tumors. Imagine catching cancer at its very first stage, when it's most curable. The human brain is one of the most mysterious structures in the universe. Disorders like Alzheimer's, Parkinson's, and epilepsy are hard to diagnose early. PET scans give some information, but they're not detailed enough. This gamma-ray camera could visualize brain activity at an unprecedented scale. Doctors could see exactly how neurons interact, how neurotransmitters move, and how diseases disrupt these processes, opening new paths for treatment. Heart disease is another leading killer. Gamma-ray imaging could allow cardiologists to map blood flow with stunning accuracy, spotting blockages and weaknesses before they cause heart attacks. Because the camera captures molecular-level activity, it could allow doctors to tailor treatments in real time. Instead of guessing if a drug is working, they could literally watch how the body responds to medication inside the patient. While medicine is the primary focus, the technology has wider implications. Nuclear safety, gamma-ray cameras could inspect reactors and detect leaks. Space exploration, they could be used on spacecraft to map radiation and cosmic rays. Archaeology, imagine scanning ancient mummies or artifacts without opening them. In other words, this invention could reshape multiple fields. Of course, no technology is perfect. There are challenges. Radiation safety. Since gamma rays are highly energetic, safety is critical. Although the doses used in medical imaging are controlled, researchers must ensure patients aren't exposed to harmful levels. Cost. Cutting-edge detectors and AI systems are expensive. Widespread adoption will take time. Data processing. The sheer amount of data generated is massive. Hospitals will need powerful computers to handle real-time analysis. But history shows that these challenges are solvable. MRI and CT scans were once experimental, too. Now they're routine. Here's where things get interesting. If we can now see the body at such detail, what does it mean for privacy? For human identity? Could insurance companies demand ultra-detailed scans to predict future illnesses? Could governments misuse this technology for surveillance of people's health? And on a deeper level, when we peer so closely into body, down to its tiniest workings, are we reducing human life to just machinery? Or are we finally understanding the miracle of biology at its fullest? Fast forward 20 years. Imagine going for a routine checkup. Instead of a stethoscope or a blood test, your doctor points a gamma-ray camera at you. In minutes, they have a complete molecular map of your body. They see a cluster of cells beginning to turn cancerous, a plaque start to form in your artery, a protein misfolding in your brain. They prescribe treatment instantly, long before symptoms appear. You walk out cured before you even knew you were sick. This is not science fiction anymore. It is a trajectory we're heading towards. The nuclear gamma-ray camera is more than just a tool. It's a window into the hidden universe inside us. For centuries, humans have looked outward, at the stars, the galaxies, the cosmos. Now, with technology like this, we're turning that same level of wonder inward, exploring the vast, intricate universe within the human body, the power to see disease before it starts, the ability to witness life at its smallest scales, the chance to understand what makes us human. That's the promise of this invention, and it may very well change medicine and humanity forever.